section 4.4, and in this section we're going to talk about factoring by grouping. Okay, before we talked about GCF, now we're going to factor by grouping. So each polynomial here will have 4 total terms. Okay, so this is kind of a process with which you are able to simplify factoring by grouping. Now, a couple things with this. Reminder, you can pause, rewind, do whatever you need to do to make sure you write things, get these things down. I'm in 4.4. It's probably going to be in the middle of your note packet. So you want to make sure you write this stuff down and these examples down so you have something to look at as you're going through the practice problem. So, first thing we're going to look at here, first thing we want to do is we want to put parentheses around the first 2 terms and the last 2 terms. Each polynomial you're going to have has 4 terms. So, just example what I mean by 4 terms, x plus y plus z plus w. These are 4 terms right there. Those are 4 terms that we're looking at. So everything's going to be 4 terms. What we're going to do is we are going to put our parentheses around the first 2 terms and the last 2 terms. So as I do that, I'm going to put parentheses around my first 2 and my last 2 terms every time I start. Okay? Then I'm going to find the greatest common factor of each set of parentheses and factor them out, just like we did before. Okay, so really, truly, factoring by grouping, guys, is not that much different than what we did with GCF. Okay, so you factor out the GCF. If there is not a GCF, then you simply take out a 1 every time. Okay, so you factor in a 1. So using each set of these parentheses, factor out what's common, or what each term has in common. Usually, what's left over is inside the parentheses. Okay? Now, your end answer is going to be, this is what your end answer will look like, what they have in common in one set of parentheses, what they have outside, or what I call left over on the back set of parentheses. Okay, so let's look at examples here. Let's start with number 1. Okay, so number 1, we have 4 terms here. 4x cubed minus x squared plus 16x minus 4. What I'm going to do is I'm going to put parentheses on the first step around the first 2 terms and the last 2 terms. And notice I leave that symbol right here in the middle. Whatever the symbol is in the middle, that's not included in my parentheses. Okay, so now what I need to figure out here is what do these guys have in common? First of all, what's the biggest number that goes into 4 and 1? Well, that happens to be 1, so there really is not a number. And do these both have x's? Well, they do. So what I'm going to do here is I'm going to use a GCF here of x squared. When I take out x squared, again, 4 divided by 1 is 4. So I'm going to put a 4 in here. I had 3 x's right here. I'm taking 2 of them away, so I only have 1 left over. Then negative 1 divided by negative 1 is negative 1. And then I had 2 x's here, but I took 2 x's away, so I don't have any x's left. And I can close that set of parentheses. Okay, so again, like I said, this is just like GCF, except we're going to be doing it multiple times in one problem. So now I need to know what's the biggest number that goes into 16 and 4. Well, that number happens to be the number 4. Notice the symbol in the middle just carries down, okay? And then, do these guys both have letters? They do not, so I'm not taking a letter away from anything, okay? So, 16 divided by 4 is 4. I had an x, they didn't take it away, so I still have that x. Negative 4 divided by positive 4 is negative 1. Didn't have an x, so I can't have 1 left over. Okay, so now, what I'm doing now, from here, I'm checking to see, okay, in this group and in this group, what do they have that's exactly the same thing? So as I look at these two, in this group right here and in this group right here, what do they have that's exactly the same? Well, I see a 4x minus 1. Whatever's in the parentheses is exactly the same. Okay. So now when I do that, when I take that 4x minus 1 here, and you see that left there in terms of the 4x minus 1, they have that in common. Now, what do they have left over? In other words, what is outside of the parentheses? That's an x squared and a positive 4. And now I am finished. I've got 2 binomial terms multiplied together. Okay, so factoring by grouping here. All right, so let's take a look at this next example. All right, on this example, again, first thing I want to do, take out and put my parentheses in here. First two terms, last two terms. This one's a little bit different because the numbers are a little bit bigger. So what's the biggest number that goes into 35 and 30? And that happens to be 5. They both have ends. They both have at least 2 ends. So 35 divided by 5 is 7. I had 3 ends. They took 1 away, so I only have 1 left. Negative 30 divided by 5 is negative 6. Had 2 ends. They took 2 away. Don't have it anymore. Bring down the middle symbol. Biggest number that goes into 56 and 48. As I'm looking here, it's going to be 8. So I'm going to take out an 8. Do they both have ends? No, they don't, so I'm not taking out any variables. Now, 56 divided by negative 56 divided by negative 8 is positive 7. Okay, I had 1 end. They didn't take it from me, so I still have it left. 48 divided by negative 8 is negative 6. Okay, and now if you look closely, you'll notice what's inside the parentheses is exactly the same. That's always going to match up for you that way. So I take what's inside parentheses, it goes first. What's outside the parentheses, or what I call what's left over, goes second. And you're done. Okay, so now you've got 2 examples here to look at in terms of factoring by grouping. You should be able to complete the problems that are on this page.